Hello, everyone. Today I'm going to talk to you about development environment and especially how to maximize your developer experience using Istio's overlay while keeping of those environment to a minimum. Firstly, let me introduce myself. My name is Sacha Bernheim, and I work at a French company called Padok. Basically, we're a company helping other companies with their infrastructure needs. I've been working there for a year and a half now, and one of the first projects I did at Paddock was building on-demand Kubernetes development environment. It was a really interesting subject, especially for me, because before working at Paddock, I've been doing a few internships as developer, and what I found out is that when you develop something on your computer, you ship when you want to ship your modification to staging. Well, often a lot of thing doesn't work because another team of developers did a few modification on another application which your app is supposed to communicate with, and nothing works anymore, and you end up losing time. So having a coherent development environment is really important for enabling your developer to be as productive as possible. So what I'm going to talk about, I'm going to show you how to use Argo Cd to build on-demand development environment. I'm going to show you what we've done during the project, what were the limitation we found out, and then because of those limitation, we asked ourselves what we could have done better. And so I'm going to show you what we imagined and what we implemented on other projects. Then I'm going to show you a little demonstration, and afterwards I'm going to do a little cost analysis of all this. So let me talk about the originals on-demand environment we built the first time. So what the company asked us was to have a completely independent environment for each team of developers. Basically, none of the URLs would be the same, and so each team would have an environment where all the applications of the company would be deployed. The idea would be to make sure that all the applications were deployed with the same version as the production one. And when a developer from a team want to try out a few modification he would just have to deploy his application with the new version and see how everything goes. Before showing you in details what we've done, let me introduce you to Argo CD a bit. So Argo CD is a GitOps tool you can install in your Kubernetes clusters. As for a lot of tools that you can deploy in a Kubernetes cluster, Argo CD comes with a bunch of custom resource definitions. The one that is going to interest us here is named application. Basically, an application is a custom resource definition where you give a Git repository URL and a directory to watch in this repository, and the application is going to make sure that everything that is contained in this directory is deployed inside your cluster. In this directory, you can have raw manifest, a Helm chart, or a customized bundle. Everything works with Argo CD. What is really fun is that you can have an application which deploys Argo CD itself, and then you can have an application which deploys all the applications. So basically, when you install Argo CD, when you start it, afterwards, Argo CD is going to deploy itself. Argo Cd also comes with a cool web interface, as you can see here. For each application, you have views giving you a lot of information, like on which commit your application is synchronized and what is deployed with the application. So here in this case, we can see that we have a config map, a service account, a deployment, and you can also see everything that is generated with the resources you ask the application to deploy. So for instance, we have a deployment, but we can see here that the deployment creates a replica set and the replica set creates a pod. It is a really cool interface for developers because they can actually see what happens inside the cluster without having to type in a few Kubernetes commands, which they would have to learn. So basically, what we imagined was to have a repository representing all the environment. The idea was to have on the main branch the deployment of everything that would be common between the different environments. So basically, Argo CD, image updater. I will come back to that later. And what we would have in the system namespace. So it's really classic stuff: an ingress controller, cert manager, Prometheus stack, etc., etc. And then we would have environment branch, and an environment branch would contain everything representing would contain everything regarding the environment of a team. So everything would be deployed in a team namespace, and that's basically it. So how the repository was organized? Basically, what we created with Helm was an environment chart. The environment chart would deploy a bunch of Argo CD application. Each of those application would deploy a web application of the company. So we created templates about everything, about the charts, about the values, about this environment chart. And to create an environment, what we would have to do was start up a script which would create the branch, copy everything from the template, replacing the templated values, and copy it in the environment branch into the right folders. And when the branch would be set up, it would trigger a GitHub action, which would create an application on the main branch. So an application which would be synchronized by the application of application. And this new application on the main branch would watch the environment chart on the new generated branch. So this would deploy all the application, all the Argo CD application, which would then deploy all the web application using Helm. So now let's talk about a bit about Image Updater. Image Updater is a tool developed by the same company as Argo CD, and what this tool does is that it will check the version deployed. It would check the version of the web application you deploy in Kubernetes. It would check your container registry for available version and compare it like to a constraint of version that you want to deploy. And if there is a new version respecting those constraints, it would commit to your Git repository, which is synchronized with Argo CD, the new version, and then Argo CD would do its job, which is synchronized version inside the cluster, and that's it. So at the time I'm recording this video, Image Updater does not handle webhooks. So basically, what it does, it will do this check at a given frequency. By default, it's 2 minutes. And so with this mechanism, we would make sure that all the application deployed in each environment would be the same one as the ones in production. But the idea was also to be able to deploy a new version of an application. So what we did was inside the M short, allow the use of something we call the override tag. Basically, if you use the override tag, the chart uh, will not deploy the version you put in the tag, but the one in override tag. So basically, everything did by Argo Cd image updater is overridden. And once you've tried everything and you want to deploy back the version from production, you just remove the override tag and everything comes back to normal. So with this, we found out a few limitations. Basically, you cannot do more than 10,000 requests per 10 minutes per IP on a container registry. So what happened was, because we deployed more than 50 application 11 times, and that we did the synchronization loop of image updater every 2 minutes. At some point, we did more than 10,000 requests per 10 minutes per IP. Why? Because actually the life cycle of image updater is a bit more complicated than what I showed earlier, and it does not do only one request per application to the container registry. It does something like three or four. So to make sure this does not happen, we shard image updater. So basically, instead of having one image updater for all the environment, we would deploy the image. We would deploy the image updater inside the environment chart. So each and every environment would have its own image updater, and that's it. And then with pod affinity and all this kind of stuff, we made sure that all the image updaters would not be deployed on the same nodes. Also, what we found out is that Argo CD does not handle well multi-branching. So at some point, we had more than 500 applications deployed on more than 11 branches. And Argo CD does not handle well multi-branching because of caching. What happens is that Argo CD can cache a repository, or actually more than one repository, but the cache is not per repository per branch. So what happens is that when Argo CD needs to check out from a branch to another to see what happens on the branch, it resets its cache. Uh, and so it will slow it down. And so what we had to do was also to shard Argo CD. And so we did exactly the same thing as with image updater. We would, with the environment chart, we would deploy another Argo CD. So what happens is that the main Argo CD would be responsible for deploying itself, of course, and deploying everything in system, and creating applications to deploy other Argo CDs, and deploy those other Argo CDs. And those other small Argo CDs would be responsible for deploying the environment chart with Argo CDMA data and the other web applications. Thus, each Argo CD would only have to watch one branch and only have to handle like 50 applications. And so everything was a lot more performant this way. We also, to reduce cost, we wanted to stop the environments at night and during the weekends. But because we had a lot of custom resource definitions in the cluster, and that we had to start up more than 500 applications at the same times, at some point, the admission controller of the cluster went into timeout and was not able to come to an healthy state back again. So what we had to do was to redeploy everything again because of the startup mechanism. So we decided to stop stopping the environment at night, which increased the expected costs of those environments. About the cost, so here is a little recap about the cost of those environments. So the Argo Cd node pool cost around $400. Why? Because well, there was a lot more than one Argo CD which was deployed. So we had a lot of pod deployed to make sure Argo CD was working. The system nut pool cost around $100 a month. And one environment would cost $250 a month. So, as I said, one environment represents more than 50 web applications. And this company had more than 50 developers separated in 11 teams. So those environments we had to deploy 11 times. And so this whole development environment costs a little bit more than $30,000 a month. So about pros and cons of those environments. Well, what we found out is that Argo CD really eases the life of developers. They were really happy about the web interface, and actually that helped them understand how Kubernetes works. So this was a great win. It also reduced the friction between developer teams. And what was really great was that every team used the same version baseline of every application. So when they shipped stuff to staging, there were a lot less issues. The cons were mostly the price. As we saw, it was those environment cost a lot, and we had an environment per team and not by developers. So yes, we reduced the friction between the different teams, but this could actually create friction between inside a team. So with all this, we asked ourselves what we could have done better, and we actually implemented it afterwards. So the idea was not to have one development environment per team, but having only one development environment and be able to deploy for an application, be able to deploy two versions at the same time, and just to route to one or the other version only using a header. So this would make that instead of deploying 11 times each application, you would have a baseline deployed once, and when a developer wants to try out a new application version, it would only have to deploy a new application once and not like the whole 50 applications. So before going into details, let me talk to you a bit about Istio. So Istio is a service mesh which you can install inside your cluster. And so what Istio does is that it will inject inside each and every pod of your cluster a proxy which will intercept all the communication between pods. It also comes with a bunch of CRDs. So you don't need with Istio you don't need to use ingresses anymore. You need to use Istio gateways. Then you need to create virtual services. Those virtual services will link a service, so a classic service of Kubernetes to the Istio gateway. And so all the network goes through the service mesh of Istio. It gives great observability and allows a lot of stuff, such as end-to-end encryption inside your cluster, rate limiting between your application, and all this kind of stuff. And I also need to talk to you about application sets. So application set is another custom resource definition of Argo CD. And basically, what an application set does is generate applications based on a certain pattern. The pattern we decided to use was the pull request generator. So basically, what happens is that when you will create a pull request on a GitHub repository, if the pull request validate a certain amounts of rules, well, the application set will deploy an application watching a directory on the branch the pull request was originated from. So the infrastructure looks like this. So for a given application, we still have an Argo CD application watching the repository. And this application, what interests us is that it will deploy a pod and a virtual service. And so that's the baseline application. And then we would have an application set watching for pull requests on the GitHub repository, and especially watching for pull requests with special labels. The labels we decided on were preview and the application name. And so if this kind of pull request is generated, uh, the application set will deploy an Argo CD application, and this Argo CD application will deploy the application, but with the manifest that are present on the branch the pull request is originated from. And so what we would change basically is the pod version and the virtual service. And what is really cool with Istio is that if a virtual service is linked to an Istio gateway, well, you can have multiple virtual service routing to the same application name, so using the same URL. And in our case, we can define in the new virtual service that we want to go to this virtual service only if we have a specific header. So now let me do a little demonstration. So here is the interface of Argo CD. So we can see here all the application deployed in my playground cluster. So here we have the application manager, which is the application which will deploy all the other application. And so let's go for the application of the demonstration. So here, so the application is named demo header pack, and so it deploys. Basically, what we want to see is that we have one pod deployed here with the version v0.1.0, and here we have a virtual service. So the virtual service is linked to the demo gateway. We have here the host name we want to use to be able to curl this application, and that's basically it. Then we have here the repository of representing everything inside my Argo CD cluster. And so if we go to this pull request, for instance, we can see here that we have the labels demo header back and the label preview. So if we go and check what changed, basically we see here that in the value we had preview enabled true, and that we specified header test MVP, and that we change the tag to v0.2.0. And if we go back to Argo CD in the application manager, we can see here that we have an application set, and that this application set deployed an application. And so if we go to this application, we see basically that everything that is deployed is the same as the first application I showed you earlier. But we can see here that we do not deploy the v0.1.0 anymore, but the v0.2.0, and that the virtual service changed a little. So what changed? We still use the demo gateway. We still use the same host, but we have here a match statement with headers and says that we have to use this exact header. We have to use this header with this exact value to access this application. And so let's see what happens. So here, so I deployed two applications, a front end and a back end. So basically, the front end just sends a message hello world, and the front end just takes this message and print it. Here I'm using a little extension called header editor, so we can see how I configured it. So basically here I give a header name and the header value I want to send when I activate this header. And so if I activate the back header, you can see here that still using the same URL, the message change. It does not send hello world anymore. It sends hello there. And if I reload the front-end application, you can see that the header still goes from one application to the other, and so the front-end does not print hello world, but hello there. Now, if I activate the front header, we can see that the backend goes back to sending hello world, but that if I reload the front, I'm using another size of font for the front end. And what's really cool is that I can actually enable both headers, and so the backend will answer hello there, and the front will print hello there, but with the other size of the font. And so that's it for the demo. So now if we go back to the limitation we found out during the first project, we don't have the same issue with image updater anymore because image updater needs to update only one environment. And Argo Cd needs to handle a lot less application, so we do not have to shard it anymore also. No, what you can ask is what about messages, because this system works really well for synchronous call. So from one API calling another API, but what happens when we go through a messaging system, or Redis or RabbitMQ or Kafka? Well, to be fair, we currently do not have a solution for messaging queues because we cannot uh, separate messages with a header. There is no header on the message. So what we thought about was, in the case of Redis, it's actually not hard to deploy another Redis just for trying out a new worker, but in the case of Kafka, you cannot deploy a Kafka each time you want to try out a new worker. So we are looking into, maybe is it possible to add a metadata to the message so that only a certain type of worker can read the message in a topic or some things like that. So no, should you do it? Well, the system is really cool and works really well, but Istio is really hard because it changes everything network wide inside your cluster. So if you're a small company and you're not using Istio yet, I would not recommend to install Istio solely for this purpose. Because if you install it only in your development environment, the network will not work the same way in your other environments, so it's not reproducible, and it's really hard to maintain. But we also are looking we also are looking into traffic and linkerd to do the exact same thing, and it might be less hard to install a traffic or linkerd and maintain them than Istio service mesh. So now about the costs. So I took back the cost from the first project, so it can be comparable. So what I did was I added a bit of price to the Argo CD node pool, uh, because well you will have all the Istio proxy inside of them. Actually, it's not mandatory to deploy the Istio proxies inside of Argo CD. You can still use Ingress and all, but just if you want to use Istio all the way through. Actually, probably why so actually, the price of this node pool would probably be less than that, because this is the price of the node pool with sharded Argo CD, and as I said earlier, it's not necessary anymore. And why the overhead of price? Well, because those proxy you have inside all of your pod will need a bit of CPU and a bit of RAM to be able to run. So it will add a little bit overhead of price to everything inside your cluster. So same thing goes for the system environment and for run environment. But the main difference is that if you have 50 application, 50 developer, you do not need to deploy the environment 11 times. Mostly what will happen is that in the average case, all your developer will need to deploy a new version of their applications. And so instead of deploying 11 times all application, you will basically need to deploy them only twice. So this comes down to a monthly price of a bit more than $1,000 a month, which means compared to the first time we tried that, we have a 90% cost reduction in the case of deploying all the applications only twice. So to conclude, I would say that Argo CD is an awesome tool for development environment. Actually, not only for development environment, it's a tool we love using at Padok. And if you never used it, I recommend you to try it right now. It will really change your life. And header-based routing really helps to reduce development environments cost, but it increases the complexity of the cluster. So maybe this system is not for everyone. Thank you for listening to this talk. If you have any question, you can ask them on Twitter. My handle is right here. And I wish you a very nice day. Bye.